An IP prefix generally describes a subnet, some subcomponent of the internet, and subnets eventually get small enough that every host sees every other host on that same subnet. If you plug a laptop with a wire into some local area network, for example, it's probably a subnet that is identified by a particular prefix. So here I'm drawing the untrusted School of Computing network, 155.98.68/23, and showing all the machines connected to the same sort of interface there in green, and some other network farther away, that's the 155.98.65 network. A machine in this subnet can broadcast using that all 255's destination address to all machines on the same subnet, and they will all get that packet. But the router here at the boundary of that subnet is obliged not to forward those kind of broadcasts. The idea is to broadcast locally and not create traffic globally. It's not frequent that a computer wants to broadcast some message to all the other computers who may be doing unrelated things, but there is one particular use of broadcasting, which is to help us get started and get an address in the first place. How is it that when you plug a laptop into your network, or when you use a Wi-Fi client to connect, that your machine arrives at an address without you picking one? The way that works is that your computer is using a protocol called DHCP to get its IP address, to get an IP address assigned to it by some server that is locally responsible for doing that. And that process is bootstrapped by using a broadcast. Your client connects to the network and it broadcasts a packet to everybody saying, I would like to discover the network. And here is an ID that I've made up for myself temporarily. Hopefully this doesn't collide with anybody else's temporarily picked ID. A server sitting on that subnet may pick up this broadcast address while lots of other computers just ignore it. And it responds with an offer because its job is to give addresses out to arriving clients. So that offer packet goes out with the same ID, and that's how the client and the server are going to communicate. And in that offer, the server provides an address that's intended for the client to use if the client accepts the offer. The server's packet goes out with the server's address because it always has an address on the local network. Also, I should point out that DHCP uses ports 68 and 69. So the original broadcast came from 68 going to 69 everywhere. And so it comes back from 69 going to the client. Now the client doesn't yet have an address, so we can't send this packet directly to the client. We can send it as a broadcast to port 68. And all the other machines that are not trying to connect, they can just ignore this. But assuming that the arriving client sees this broadcast message and it decides to accept this number as its own, then it will send a request and say, yes, I really would like to accept that offer. Includes the same ID, and that's how the server knows what is being accepted. Typically, the client has not started using that address that it was offered, because it wants to make sure that it wasn't too slow accepting the offer or so on. There's going to be one more round of confirmation. The server will acknowledge for that confirmation. And at this point, now it really can use that address that the client has agreed to use. And now the client is off and running with its own local address automatically discovered through DHCP. It relies on being on the same subnet as a server and there being a server whose job it is to resolve these requests. Typically, that server is running in like the firmware of a router, like a Wi-Fi access point that is attached to a local network.